So yeah, thank you for letting me present this meeting. And as you can see in the headline, it's something about TestStand, and you can see I have the TestStand API poster behind me right here, at least virtually. So I've done a lot of TestStand work in my career. So I'm going to try and share my screen in just a second here. Let's see here. So it's going to be this one. And so, do you see my screen now?
Yep.
Great. Okay, let's get started then. So I'm going to talk about custom step types for TestStand today, and about how to make custom step types. But first, I'll just do a short run-through introduction of what it is and when to make custom step types. Let's see if I can actually change screens here. Short on me. I'm Jens Christian. I live in Denmark. I work for GPower. I've done so for 10 years now. And as you can see, I've also worked with LabVIEW and TestStand for quite some years. So the topics of this presentation, just a run through of those. So let's look at what is actually a custom step type for TestStand. When should you consider creating one? When you want to create one, what are the requirements, scope, and functionality that you should consider? And then we dive into like what is some of the internals, the data inside a step type that you need to know about. And functionality and configuration is actually where I go a little bit out of a limb here, because I'm going to attempt to create a custom step type in TestStand live in a virtual machine as you are watching. So let's see how that goes. And then I will talk a little bit about deployment and maintenance at the last subject here. And if we have time, there can be some questions in the end, I hope. Okay, so let's look at this. What is a custom step type? So TestStand actually ships with many step types, which you can see here in the insertion palette of TestStand. And you can just drag one of those into your sequence, and then you have a new instance of a step in your sequence, which you can then configure in the step settings pane in the bottom of your sequence editor screen. Like here for the message pop-up, you can type in something you want to display when it shows as your sequence is running. Right. So custom step types are kind of the same, except that you are the one making them. So you can build your own step types, and you can have them displayed here in the insertion palette together with all the built-in step types. And you can also just drag them here from your insertion palette and into your sequence. So this is a LabVIEW user group, and the step types that we're going to look at here is also made with LabVIEW, or rather the code modules that run in the step types are made with LabVIEW. But when you do that, when LabVIEW, you don't get to use the nice step configuration thing in the bottom of the screen. In the bottom, you just get this kind of an edit button you can press, and then you can open a VI front panel to configure your step types. So because it's LabVIEW, you can't use the fancy edit stuff down here, only this one. When you press this button, you open a predefined VI front panel that you have decided when you created your step type. This is an example from GPower. This is how it could look. It could look in many different ways. You can do the layout of your VI front panel as you like, but you can configure your step here, and then you can press the OK button to save the configuration into your sequence. So that's the basics, sorry, of what a custom step type is when you work with this in TestStand. I hope some of you already know about this or know about TestStand and step types in general, or else this might be a little bit difficult to understand. So when should you create a custom step type? So actually, when I was preparing for this presentation, this headline was different. It was like, when should you use a custom step type? But then I thought, well, if you already have a custom step type that is made for the instrument you're going to use, then you should, of course, use it. I mean, that's the thing. If it's already there, don't do anything else. So only if you are in the progress of having to use some kind of hardware or whatever for which you do not have a step type, then you should consider maybe making one. Maybe you can get away with just creating an action VI, an action step to start with, but at some point you might want to consider using or creating a custom step type. And as I see it, there are two major scenarios where you would go into this consideration. The first one is refactoring. If you have some code that has been running in your sequence for some time, like an action step in a sequence, and maybe the complexity of the code or the requirements for the ability of, to configure the behavior of the step has grown over time, it could be that it's being increasingly difficult to actually maintain this step as you would like to. So this would be a good point where you would start, okay, maybe I should like refactor this code into a custom step type and make it into that instead. The other scenario is if you're building a new test platform. If you're a test platform developer and you are building this new test platform based on TestStand for your multi-team company, where maybe many teams in many different sites will be developing test sequences using this test platform. You might want to make sure that they are consistent in how they build the sequence and which tools they use to build the sequence with. And that could be a reason to create a bunch of custom step types for your sequence developers to make sure that their work is easier and more consistent throughout your company. I need some water. Right. So let's say that you have decided now that you want to create your own custom step type. Then you have to consider these points here: requirements, scope, and functionality. So in that way, this is not much different than in any other software development tasks that you might be doing. So the first part here is requirements. So you have to be clear about what is the requirement for your step. Like, must it be thread safe? I would say in most cases I make the step types thread safe. It means that they can run in parallel executions in your sequences, so you can have more instances running at the same time. It must be able to include its results in a report if it produces any results that need to go into reports. And of course, you must make sure that it's compatible with the TestStand version or versions that you use in your company. You have to be clear about what the responsibility of this step type is also. So that's part of the scope, the purpose, and the responsibility. You should try not to cram too much responsibility into one step type, because then it might be very difficult to maintain and difficult to use in time. So it's very clear. It should be very clear what it should be, what the scope and the function of it is. And that brings us to the last one, which is functionality. You need to know what your users are going to use this for, and you should try to only perform one function in each step instance that you put into your sequence with your step type. So this is a bit like every other kind of software development task that you might do. If you modularize it, if you make it clear what is where's the boundaries between different functions, different interfaces, then it's much easier for you to work with and maintain going forward. Okay. The next part here, we dive a bit more into what is how is the step type defined inside TestStand, so to speak. So this is a screenshot from the type view in TestStand, and here we have a view of 4 step types. I'll just try to find the laser pointer here so I can point to what I'm showing here. So here we have 4 step types. The step types in TestStand should be stored inside a type palette file, so that you have one place that you say, this is where I go to edit this step type when I want to change it or do something with that. So you can have like one or several step types in the same type palette file. In this case, we have all 4 of these in the same type palette file. So each step type will have some data in it. It's called properties in TestStand. And this is an example of properties in this step type called write tag here. And these properties, they can be, in general, they can be grouped into 3 groups. One of them here is the built-in properties. They are properties that that are just part of all step types in TestStand. They are mandatory, defined by TestStand. They must be here, because if they're not here, then this is not a definition of a step type. They are the same, and they cannot be changed in the step instances that you might be working with in your sequences. Then there are something that called default properties, and they are also mandatory and part of the definition of the step type. But when you drag your step into your sequence, these are properties that will have some default value to start with, but you can actually change them for your step instance, and they can be different when you run the step in your sequence. And then, of course, there's custom properties, and they can be anything, because you are the one who create the custom step type, so you decide what custom properties goes into your step type, so you can do that as you wish. So the built-in properties are accessed by right-clicking on your step type definition, go to the properties menu, and then you open. There's somebody talking here. And then you open the properties dialog to see the built-in properties of the step type. And the default properties, they are very neatly named with the name default in front of their names in the dialog here. So they stand out like that. Okay. So we get to functionality and configuration. When you create a step type, you would like to have some run code. It means the code that is running when you actually execute your sequence. You have some editor code that is like the VI front panel I showed you an example of earlier, where you can edit the configuration of your step while you're in edit time. And in some cases, you might also want to have localization for your step types, so you can have different languages depending on what you select for language in TestStand. The code modules, the run code and the edit, they are set up in here in the sub-step tab of the properties dialog. As you can see here, here's a run code. This is the VI that will run when the sequence is executing the step. And the edit VI here is the VI that will be executed when I press the edit button to configure my step type. Great. So from here is where I will switch to my virtual machine and start doing something actual live. I have started TestStand up already because I want to save time. So what I want to do now is go into the types menu here, tab here, and I want to create a new custom step type. And I would like my custom step type to reside in its own type palette file. So the first thing I'm going to do here is I'm going to create a new type palette file. And I'm going to call it NORDLUG demo, like this. So now I have a new type palette file. It's listed as an INI file for historical reasons only, because it hasn't been an INI file for decades, I think. It's not something you can open and edit in a text editor. It is mainly a binary file, but the extension is INI. So now I have this new type palette here, and I can go and create a new custom step type like this. And as with any other property name in TestStand, you can't use spaces, so you have to use like underscore or some other character instead of a space character. Right. So now I've created my first custom step type. So what I want to do now is I go into the properties here, and I go in here, and I want to select the code modules that I'm going to use. So I'll start by adding my edit code module here, and then I'll go and specify the module. And I have, of course, prepared some code for this that we can use. So it is not in here, but it is in my step types. And I have this PPL where I have my code, and I will select the edit VI for this. It will now load the VI, and you can see here that this is the VI that I have chosen. It has some inputs and an output. So here is the sequence context. I always put the sequence context as an input on the VIs that I make, because it makes them more future-proof. It means that if I, for some reason, from in here need to get access to more TestStand properties when I am editing or running the sequence, this is a place where I can get that access without having to change the connector pane of the VI. I can just use the TestStand API functions inside the VI. So I have to connect this, and it's just this context. It means I will just get the context which I am working in when I'm working with this. So the next one here, it's a cluster, a LabVIEW cluster that's going into this VI. And I would like to have a type in TestStand that mirrors or reflects this LabVIEW cluster. So I'm going to create that from here. Like this. And I want it to reside in the same type palette file as my step type, of course. Create. So now I have created a new, not custom step type, but custom data type, as you can see here. Great. So I'm just going to leave this for a second to go in here and make sure that you can see now I have this new custom data type here, and I now want to make a variable or a property inside my new step type with this type I have just created. So I'm going in here. Here we go. I'm just going to call it parameters. Right. So now I can go back in here and edit this one again. And now I know which variable I want to use. So I'll just go here and say, I just unfold this so you can see that it will actually get filled out. Sorry. Like this. And you can see now I have the variables that I want, and it reflects my LabVIEW cluster perfectly. That's the input, and if I edit the stuff, I want it to get out again and get saved in the sequence, so I will just put the same variable here. So I read it, I edit it, modify it, and I put it back out in the sequence again when I use my step instance here. Great. So now I have my edit code in place. So the next thing we're going to do here is to add a post step for the run code. So let's just call it run. And yeah, let's specify the module, and then I will talk about afterwards why I am using a post step for the run code, because that might seem odd to people if you're not used to it. But I'm going to go in here and I'm going to select again a VI from my PPL here. It's going to be the run VI. Again, I would like to have the context here. And of course, my run code needs to have the data that I configured, and it needs to execute code on that data. So I have to point it to the variable that I selected here, like this. Right. And you can see also I have an output here called success. So I would like to store that somewhere also. So I'll just go out here and I'll go back to this and I'll create a new field called success, also a field or a variable inside my custom step type, as you can see here. And I will go back and I will, let's see if I select this correctly, like this. And I will specify that variable as my output from here. So now I actually have configured a step type. You can do more stuff with this. Like I could say, what would I have like to? What should the button text say when I press that? It could be configure. Sorry, it is a string. I have to do this. Configure step, something like this, right? But the question I asked before is that why would I use a post step for my run VI? Because some of you that have maybe worked a little bit with TestStand and custom step types before, you will know that out here there is something called a default code module that I could just select for my step, and then that would be executed when the step is running. So the reason that I'm not using this is because this is intended for you as a sequence developer, that you could put in a step instance specific code module. So when you drag your step from the insertion palette into your sequence, you could go and select yourself a code module, a VI of some sort, that would be run here, but it would be different for each step instance of this step type. But the run code that I do here must be the same run code for every instance of the step type that I'm running. So that is why I won't use the default code module for this. I have to use a post step, and that is actually also what NI proposes as best practice for running your code like this. So I'll set this to none, because then I won't be asked to select a VI for this step type, and I don't want to be able to be asked that. Right. So yeah, let's leave this. So now I have a configured step type, and you can see it's already in here in my insertion palette, and I can now drag it into my sequence. And as you can see, it says configure step here, because that's the string I typed into the button, as you saw, or as the menu button you saw before. And if I press this one, it will open my VI front panel. And this is just for something where I can type in an IP address of some sort, and I can set these variables here. And if I say OK, and I open it again, it will remember what I did, because it is stored inside the step parameters of this specific step instance that I have been putting into my test sequence right here. And of course, I can right-click this one, and I can say I want to run it. I don't want to save this one. And it's a bit stupid because I used the 3-button dialog in LabVIEW for this, so it won't show up. But I can show it like this, so it'll just display the settings that I put into the step. And as you can see down here, I have a preview a variable here because I have the success output, and I want to show that here. As you can maybe see down here, it's a little bit vague in the colors, but it says true for the output. Okay, so I've just built a custom step type here for you to see how it works, how you get started with doing a custom step type. And I'll just switch back for a moment to the presentation, because the next thing, or the last subject here I'm going to talk about, is the deployment and maintenance of your custom step types. Now we have made a custom step type. We have the LabVIEW code. We have the definition of the step type in TestStand in the type palette file. But how do you actually make sure that you have a good and robust way of deploying your step types onto your test systems? So you keep a solid process by doing this. You build your code, you package your builds, and you keep track of versions. These are very important things that you have to consider doing when you are making custom step types or any other component that you want to deploy to your test systems. So always build your source. Never ever do this. So never just make some LabVIEW VIs, put them on your USB stick or whatever, and copy them onto some folder on your tester and run it from here. Yeah, and why shouldn't you do this? Well, because it will cause you all kinds of linking problems when you do this. Many problems will occur from this. So don't do this. I know I have done so in the past before I knew better, but it's not a good thing to do. What you need to do is to apply a build process to your code, and then you need to somehow move your build output on to where you need to have your test steps located on your test system. So this last part here of moving it, I mean, the output could be a PPL as I prefer. It could be a source distribution, but it's some kind of output that has been through a build process is important. And how do you do the last step here of moving it? Well, you could just move it like a file onto the test computer, but a better way of doing this is doing some kind of packaging and have a package manager control which versions you are using. So you should do something like this. So the process here is extended with a package building process, and you end up with a package output here. Because when you build your your step types for TestStand, you might not just want to have the code distributed or deployed to your system. As I talked about, there can be language files, there can be icons, there can be other kind of files that you want to also distribute with the code, so that you have like a complete package with everything that goes into your custom step type. So then you can use a package manager and you can run the installation process, and that will be the one that helps you do the last step where you move all of your files into the correct locations on your test systems. Right. So let's have a short look at this. I'll just close TestStand here. And I have the code here, the LabVIEW projects that I have created to demo this. So this is like a further version of what I started doing before. I started making my my custom step type inside TestStand with a definition. That definition is now living here in a file in my LabVIEW projects together with other files. Here's the library that will be my PPL. It contains some VIs. And then I have my build specifications here for the PPL and for the package. And then when I have this all together here, I can take my package that I have right here, and I can run the installation with the NI Package Manager. And it's a little bit slow in starting. I can see I'm behind on time already. Wow. I hope it's okay. I don't have that much left.
You're also starting a little late, but yes.
Yeah.
We will try to keep the more or less the time.
So here I'm installing the custom step type with all the files that I wanted it to be installed with. Let's see if it goes right. Take some time. Yeah, it did. Great. So now I will just open the package manager and refresh the view in here. And you will see now there's a NORDLUG demo step type in here in version 1. So the thing about packages is that you can see which version you have in here, and you can also make them dependent on other packages. So you have a control over what kind of dependency structure you are applying to your test systems. That's why packaging is a very good application to use here. And you can see now we have a new folder here called NORDLUG, and the step is in here, and it has a nice icon here, which you might recognize, and it's the same as before. It just have to start up the LabVIEW runtime engine here, and you can see it's the same as you saw before. So that is the way it's installed, and it is in here in the same way as we saw before. Sorry, here it is, like this. Okay. The last thing was versioning. So when you have a step type, there's a lot of places where you have to keep track of which version you're having. So the first one up here is for the definitions inside TestStand. This one is for your library in LabVIEW, and this is for your package build specifications or your PPL build specifications. So I just want to say that the thing you have to be aware of, always keep at least the major version synchronized between these. So it all must be the same major version. If you change the major version in one place, you should change the major version in all the places to make sure that you have some kind of control of this. If you have more than one step type in your type palette file, it would be okay if the minor or fixed versions are a little different, because you might just have changed one step type in there and not all of them, but keep the major version in synchronization with this. Great. So I had planned to show you one of our real step types from GPower, but I think we might be out of time. Or Anders, what do you reckon?
If it's only 5 minutes, I think it's okay, unless there's a lot of questions.
Yeah, of course. It's only 5 minutes. If it is. I just want to open it up and show you what we are doing with that. So the step type is actually installed here, or step types. So this is the group of step types. You can see there's 4, the one that I was talking about or showing before, and we can put them in here and stuff like that. But I wanted to show you the LabVIEW project that was used for building this. And there's one thing I can talk about when this is loading, because we're using this here in TestStand. You can actually get all LabVIEW types in and out from your VIs to TestStand and back again with the API, except one. That is LabVIEW objects. You cannot read or write a LabVIEW object using the API. You have to use the connector pane of the VI to get those in and out, and that's sometimes a problem. So what we have here is one top-level library here, and then we have sub-libraries for each step type that we create, and then we have one edit VI for them all. And the edit VI looks like this, and I don't know if I can run this without an arrow. I can just try. But what it does is that we have this tree control here, and then we utilize the expression edit control of TestStand. I don't think this will run. Oh, it did. It did. Great. So if I put the mouse here, it brings up like the expression edit control and fits that to the field that I'm at in the tree control, so I can use all the variables in TestStand from here to get my configuration going, and that's a nice thing to do. So different same edit VI but different step types in here. And you can see here there's a lot of extra stuff going on. Also, there's some extra VIs here for deployment, so that I make sure that I get the nice extra folder in the insertion palette that I can install this this step type on different TestStand versions and stuff like that. There's a lot of extra that we have put into this to make sure it all works. You can just the last thing here, you can see that in our package build specification that we have extra stuff going on to make sure that we can accommodate all the things that we want to do. You see a lot of posts and pre-on installed stuff going on in here to make sure it all is all put into the right places. Right. Yes, that's all about it. So this presentation was inspired by the TestStand custom step type development best practices, which is on the NI website, and I would recommend you to go and look at that. I can share a link in the chat after this so that you can actually see what's going on there, because it's a very good starting point if you want to learn about how to best create your own custom step types. And that's it. Time for questions. Okay.
I can't see many others. One fast question. Maybe not. No.
I think Anton, you raised your hand during the presentation. Do you still have the question, or is that answered?
No, that was a mistake. I tried to react, but I raised my hand. I just want to agree to the comment that you need to have build and deploy process and not just copy paste stuff over. That just solves so many headaches.
Yes.
Yeah.
It's Christian. There's one in the chat from Iskander. There's actually a couple. Maybe you can start with those.
Yeah. I'll just stop sharing then, and I'll just go and see what it is in the chat. I haven't seen that yet. Okay. To have shared variables. I'll see what shared variables, custom step using locals, file globals. Shared variables between relate. Yeah. So yes, actually, I think I know what that question is about, and you must correct me if I misunderstood that. But actually, that is what we do with the step type I was just showing shortly before. We have like a session object, and that's why I talked about the LabVIEW object. We have when we open a session to this, this was an OPC connection we were talking about here. So there's a connect and disconnect step, and the connect step, of course, creates the session, and I want to share that session with the read and write steps further on in my test sequence. So yes, you can store variables from your steps in TestStand, in locals or in file globals or whatever, and reread them in the other one. We do that with this LabVIEW object that we pass into a variable in TestStand, and then the other steps will use that session variable to continue. Yeah, and we had to do some hacks to actually do that in a good way, but I can show you that later on if you want. Let's see, if you choose a different adapter for your step type, is the step settings part better integrated? So yeah, so if you do a step type where your code is done in like a C#, then you can have better integration with the step settings pane in TestStand. Actually, I went to a TestStand meeting. I think it was a closed door meeting back in 2016 at NI Week, and it came up, this thing, and we asked if the TestStand people there, if it was something they could do for better, and they said yeah, but would it have to work for LabVIEW? And we said yes, and they're like, yeah, it really they didn't want to do that, or they couldn't do it. I don't know. So yes, if you do it with a C# or something, you can have better integration with that.